Hey everybody, we are using our calculators to get our instantaneous rate of change, that derivative, well, an estimate anyway, using an equation. So this is the example that you find on page 3 of the textbook. In my y equals, I've entered my equation already. One thing to notice, this guy right here, this negative, make sure you use the negative button, which is to the right of the decimal point, not the subtract button. Those aren't the same thing. If you use the subtract button instead of a negative, you would get an error. So once I've entered this in, I can quit, so second mode, to get to the home screen. Our goal is to find the slope from 1 to 1.01 because that will estimate the exact slope at x equals 1. I could get a better estimate if I went from 1 to 1.01 or 1 to 1.001 and so on. But 1 to 1.01 is fine. So to do that, it's change in y over change in x, right? So f of 1.01 minus f of 1. To do that, if you have a TI-83 or TI-84, you can get y1 on the screen by pushing the button called vars, as in variables. We're talking about y variables, so I arrow to the right. We're talking functions, so I hit enter. And then here's my giant list of all the function types, so I hit enter. So I just pulled up y1. Now I have to tell it what to evaluate. I use my parentheses, just like function notation. So parentheses, which is above the 8, 1.01, parentheses minus, and again, I can get to that y1 by going vars, y vars, function y1, and then I can do 1. I don't have to close the parenthesis here, but I will, but you could leave it open as well. Hit enter. So here's my change in y, which is very tiny, and then divide by the change in x. So I can go divided by, and it just pulls the previous answer, 1.01. So here's my estimate of my slope at x equals 1. If you have a TI-84, another way you can get that y1, besides the vars, y vars function y1, you can push the alpha and the trace, alpha trace, and there it is. I can hit the 1, so it works the same way. So just to show it again, I'll find the slope from 1 to 1.001. And then minus, and then alpha trace, 1, 1, and divide again by this time 0.001 because that's my change in x. So now I have 3.64. So this 3.640 is a better estimate than the 30.234 I had before. But both of these provide good estimates of the slope of this function at x equals 1.